Okay, good morning, good afternoon, and good evening, depending on when you listen to this slide presentation. So my name is Victor, and I'm going to be your anchor for this training. This is the Cisco ITN, Introduction to Networking. Is a three-part series in the CCNA, Cisco Certified Network Associate certification. We've done module 1 up to module 6. So this is the 7th module, Ethernet switching. Okay, what's our goal in this module? We want to learn about how the switch works, how the switch does, what's it called? How it does the forwarding of packets across the switch with the help of the MAC address. So the MAC address is very important when it comes to how the switch operates. Because don't forget, in the previous module, we said there are several types of addresses. You have the loop back address, you have IP address, you even have the local IP address and the external IP address. You have the MAC address, right? And for the IP address, for instance, you have IP version 4 and IP version 6. Then at layer 1, we said layer 1 is the physical layer. Layer 2 is the data link layer. And at this data link layer, where you have your switch, that's where switching happens. So we want to explain the Ethernet sublayers and how they're related to the frame fields. Now, when you say frame, you say that packet of data, what its components. They want to describe the Ethernet MAC address, want to explain how the switch builds its MAC address table and forward those frames. Now, you also understand that every switch is going to have a what you call a CAM table, content addressable memory. What you're going to have there is the MAC address, so that whenever you forward item from one PC to the other, whenever you forward items from one phone to the other, you can fully understand who has that particular item. So in a network where you have items like PCs, computers, laptops, printers, and the rest, for each guy that is going to be on the network, they're going to have a card, an NIC, a network interface card. So it can be wireless, it can be LAN, right? So the point is that each of them, whether it's wireless, whether it's on phone, whether it's mobile, whether it's printer, they are going to have a MAC address. And of course, the switch is going to have a table where it has all of this MAC address, so that when any person sends any information to the switch is able to forward that particular packet. Then we're going to learn about the switch speed and forwarding methods. So what are the different methods that the switch can use to forward these packets? Then let's start with Ethernet frames. So of course, it's the layer 2. The Ethernet operates the data link layer and the physical layer. Yes, these two guys, because that's where you have the physical NIC card. Then this is where you have the switch operating. This is where you have the MAC address. Now, it is a family of network technologies defined in the IEEE. So that's the Institute of Electrical and Electronics Engineers. We have the 802 and the 802.2 and 802.3 standards. Of course, the 802 has to do with the hardware. This very first layer. The 802.3 has to do with this netware, the second layer. So these are just different standards to help manufacturers and vendors know how to manufacture their hardware, so that there is interoperability, so that different devices from different vendors can interoperate. So the 802 LAN or MAN standard includes Ethernet that has two separate sublayers. So you have the LLC, the logical link control, and the media access control sublayer. So you have the LLC sublayer and the MAC sublayer. So this is the 802, and this is the 802.3, 802.2 and 802.3. Of course, this second layer, it's not responsible for data encapsulation. So it's going to pick up whatever it takes from the physical layer, wraps it up, and send to the third layer, which is the network layer. Then, of course, the network layer have to now de-encapsulate what it has received, add some more information to it, encapsulate it, and now send over to the subsequent layer. Okay, that's that. Anything here? So we talked about the LLC. For the media access, the MAC sublayer includes specifications for different internet communication standards over various types of media, including copper and fiber. So imagine the point is that you are going to be utilizing, you're going to be having your network coming from different means. It might be coming from, it can be coming from, let's say, my regular ISP that gives me internet or network over point-to-point connection, maybe through a consumer premise equipment, or it can be a regular connection that's going to be coming from fiber optics. It can be coming from any way. But the thing is that the standard helps this manufacturer to prepare these hardwares to comply depending on how you're going to access your network. So these are just sets of standards, whether you're using normal copper, a Cat5, Cat6, Cat, whatever cables, or whether you're using fiber optics, it doesn't matter. It's going to be compliant. So that's what the standard helps us to achieve by IEEE. Legacy Ethernet using bus topology or hubs is shared half duplex. These are more older topologies. They are more or less obsolete. Ethernet over a half duplex medium uses a contention-based access control access method, or carrier sense multiple access collision detection. So normally it will detect whatever collision. They're not as intelligent as recent full duplex connection. The reason be that remember when you had hubs, when you had older type of topologies, what will happen is that if 5 systems on the network is connected to that particular hub or that particular switch, what will happen is that most times they are not able to, they're able to just detect collision. They may not be able to do correction. They may be able to, they're not as intelligent as the recent routers, the recent switches you have, or the recent topologies that you have. So this is more or less legacy, like we said. So most of the time we just have, if you have several carriers, several nodes on your network, several PCs, several end devices, they could have multiple access and they will just detect whatever collision. Collision is when you have more than 2 guys trying to make access, more than 2, 3 guys trying to send item to one PC or whatever, or trying to communicate. Whereas Ethernet LANs of today uses switches that operate in full duplex. So that is 2-way communication. So everybody can be sending at the same time and they could have all of that information, and they are very, very much intelligent. That's why you normally see older topologies, older hubs, older switches are not intelligent. Why? They don't know how to do traffic management. Imagine if you have a child trying to do traffic management in a roundabout or in a junction, a T-junction or a star junction. It's going to be very hectic. So you're going to be having collision. You're able to detect the collision. Oh, I might have this car have a jam with another car, but the guy might not be able to correct, right? Or drop errors. So that is what more recent switches do for you. Okay, so you have the Ethernet frames, it's 64 bytes and a maximum of 1518 bytes. Any frame less than this, it's considered a collision fragment. So of course, it's not able to run through that. So most of the times it drops it. If the size of a transmitter frame is less than the minimum or greater than the maximum, the receiving device drops the frame. So that's one way it could do a correction, so that you don't have a situation whereby you have 10 systems and after some period of communication, they don't just see themselves again and you have to restart the switch or you have to restart the hub. That's what is obtainable back then. So there's a Cisco lab here. I had to use Wireshark to examine Ethernet frames. So we're going to do that separately in another video for all of the labs in the modules. We'll record that separately and add to the channel. So you have, so we look at Wireshark is a packet sniffing protocol inspection and capture tool. We could use it to investigate what happens in our network at the several layers. So we'll do that separately. The MAC address. I mentioned earlier, the MAC address is a 48-bit binary value expressed in 12 hexadecimal. When you hear the word hexadecimal, you mean from 0 to 9 and from A to F. So I've showed you what the MAC address looks like. So it's also called the physical address. That's what is ingrained in the NIC of any device, the network interface card of any device. Okay, so this is what it looks like. You have some OUI and the vendor assigned. Now, IEEE is going to see a way to identify a portion, the first 3 portions of any MAC address. Then the vendor itself will assign its own naming or whatever to the MAC address. That way, devices are going to be able to communicate without issues. So if a hardware manufacturer, not necessarily are you going to be your NIC manufacturer. So you have several companies. If you Google that up, you're going to see there are several companies that produce NIC cards. So HP, for instance, Toshiba, Dell, all of these, or Brother, all of these printer and wireless printer or LAN-based printer or TV. You see smart TV these days, they have a Ethernet port. The issue is that they might not be the guys manufacturing those NIC cards. Another manufacturer is going to manufacture that, so they just buy, couple, and assemble. But the thing is that IEEE, it's going to see how to identify them, and you're going to know that by the first part. Then you can also know a MAC address when you see it by the last 3 parts. It's normally 1, 2, 3, 4, 5, 6. So these 3 parts, you can always know the manufacturer by that. If you do more research on this, you'll see that every manufacturer have a way they name their MAC address. So when a device is forwarding a message to an Ethernet network, the Ethernet header includes a source MAC address. Like I said earlier on, guys will not be able to communicate on your network if they don't know where a message is coming from and where it's headed to. So that's why your CAM table is going to have all of these NIC card. Sorry, they're going to have all of these MAC address of whoever their sender is. So at layer 3, when we start considering that address resolution protocol, we're going to see that another information that you can add to a message is the IP address, right? We need to know the MAC address, where it's coming from, and also the IP address. With these 2, that's what makes our ARP table. ARP table is going to be having our MAC address, have our IP address. So we actually know the identity of this system. So look at this illustration here. You have system 1, system 2. This is mine, H3. This is not addressed to me, I shall ignore it. So the guy can always understand, because the switch knows what it should forward to this guy. And the job of a switch is to forward packets, forward traffic. That's the job of a switch. Whereas the job of a router is to transfer packets and data from one section of your network to the other. For instance, what your router does for you at home that provides internet is to forward all of the traffic you have within your home away through to your ISP, to wherever that's going to go. So you have in internet, MAC addresses are used for layer 2 unicast, broadcast, and multicast communication. Yes, of course. So if we're going to be shooting out message to either it's a unicast or a broadcast or a multicast, we explained that earlier on. A unicast is just 1-to-1, a broadcast is 1-to-many, a multicast is 1-to-many, and the broadcast is one to all. So whatever I'm sending information, if this switch is trying to forward information, it needs to have those MAC addresses. If it doesn't have that, it's not know how to forward whatever information it's getting from different persons. Okay, same thing here. Yes, same thing here, same concept. Yes, so there's a lab here. We'll do that separately. Set up a topology, initialize devices, verify connectivity by doing pinging and the rest, then run IP config and the rest to display what the MAC addresses are. We did that in the previous classes, but we're going to do all of this in a separate lab. Okay, the MAC address table, right? Like I said, that's what have the MAC address of all of these guys. So the MAC address table is sometimes referred to as a content addressable memory. So when the switch is turned off, the MAC address table becomes empty. So once it's turned on, what the switch first does is that it learns and tries to ping all of these guys, run some ICMP commands to understand what MAC address I have and the rest. It now keeps it in a table. So whenever you now send information to somebody else via the switch, it knows who to send it to. Okay, so that's it. It learns. Once it learns, it can be able to forward data. Okay, there's a video in your LMS, your Cisco Learning Management System, that shows you how the switch builds its MAC address table and how it forwards that to the different persons that they are meant for. Okay, there's also a video on this. There's a lab here. Switching speeds and forwarding methods. So you're going to have different speeds that my switch is going to have, and the different methods you can use to forward these packets. Let us look at few. Store and forward. So here, no error correction, right? So this frame forwards method receives the entire frame and computes the this should be the CRS, right? Yeah, so that's CRC, which is the like your cyclic redundancy check. So this is what the guy uses to try to calculate if you have redundancy, if you have errors, if you have issues, right? So before the guy does all of that forwarding, it tries to check for all of that. So if it's valid, then the switch looks up the destination address, then determines the outgoing interface, then the frame is forwarded out of the correct port. So this helps for mitigating having errors, having issues with regards to switching. Then you have the cut-through switching. This frame forwarding method forwards the frame before it's entirely received. At the minimum, the decision address of the frame must be read before the frame can be forwarded. So you're going to have a lot of errors there because there's no redundancy check. A big advantage of the store and forward switching is that it determines if the frame has errors. Errors, CRS. So the guy checks for errors, switching CRS in Cisco, right? So we're looking at, let me see, cyclic redundancy check. Redundancy check. Yes. So a CRS is an error detection mechanism commonly used in computer and storage networks to identify data changed or corrupted during transmission, right? So it does that check. So if there's an error, it drops it. If it's all fine, if it's all valid, it forwards the packet. So it's very good. It's very good, right? So discarding frames with errors reduce the amount of bandwidth consumed by corrupted data. Store and forward switching is required for quality of service analysis on converged network. Converged network would mean networks that have voice, have what's it called? Voice over IP, has data, and have what's the last one again? to update the three major items you can have on the network: voice, data, and forgotten the last one. Okay, so this is it here again. First, forward switching. Then you also have fragmented switching. These are other methods of switching. Memory buffering. So just like anytime you hear the word buffer, anytime you hear the word memory buffer, you want to say, how do I have a bridge? How do I have something that tries to be a bridge for me between my receiving something and sending something? For instance, if you are streaming a video, if you don't have enough video memory, or if you don't have enough RAM memory, you might not be able to buffer properly. Or if you have okay, so these different methods, either the port-based or the shared memory-based, right? So straightforward. I've talked about the full duplex and the half duplex already, where in half duplex, only one end of the connection can send at a time, whereas in full duplex, you can have back and forth simultaneous communication. So most recent switches and routers have full duplex, right? Gigabit Ethernet ports only operate in full duplex. Yes, they are that fast, so they could do multiple things at the same time. That's why you have a higher speed. Okay. Yes, so if this guy is full speed and this guy is half speed, of course, you're going to have issues, right? Things are not going to be as fast as possible. Okay, so the auto MDIX is what does that feature is what does the correction. You can always configure that on older switch table to enable that. Okay, that's all for this module. What have we learned? We've learned that Ethernet operates in the data link layer. That's where you have the MAC address. Then we said MAC addressing provides a method for device identification. Yes. And it's at the data link layer of the OSI model, at this point. Then MAC address is 42 bits. And we need a CAM table, a content addressable memory, to be able to have stuff that has to do with our MAC address for identification purpose. Okay. Thank you very much. Make sure you like or subscribe. See you in subsequent modules.